Okay, so before we dive into ellipses, we'll do just quick brush up on parabolas. And remember, it's not parabolas as in functions. It is parabolas as in conics, which means our equations are different. So if the coordinate point, if the vertex is at 0, 0, you had one function equation, and then if it wasn't, you had the other. So if it was y minus k squared equals 4px minus h, this is a y squared, so this means this faces to the right or to the left. The p is the distance from the vertex to the focus or the vertex to the directrix. And then if it was x minus h squared equals 4px, or sorry, y minus k, then this opens up or down. Positive up, negative down. On the y squared, positive to the right, negative to the left. And then if it had a vertex at 0, 0, there just wasn't an h and a k. Everything else was the same, okay? So all of that obviously is a parabola, and the easiest way to spot it is there's only one thing squared. So if there's only just the y squared or only just the x squared, then I know I'm talking about a parabola. When we get into ellipses, now we're talking, you're going to see the equation change, but an ellipse is an oval. So it has an oval shape. It's either a vertical where it's taller than it is wide, or it's horizontal where it's wider than it is tall. So ellipses look like this. By definition, an ellipse is all the set of points in a plane, the sum of whose distances from two distinct points is constant, okay? Obviously, you're not going to be tested on vocab. More importantly is, can I identify it, 1, from an equation, or 2, from the graph? So you're just like we did with parabolas. Today is going to be about graphing the ellipses, and then tomorrow will be about finding the equation of the ellipses. So there are 2, like I just said. The first one is horizontal, and that means it is wider than it is tall. The second is vertical, and that means it's taller than it is wide. They all have a bunch of parts to them. They all have a center, so the center is at the middle. Okay, your center in this case is at 0, 0. It can shift. They have 2 types of vertices. The first is just your regular vertex. There are 2 of them. And that's going to determine if it is a horizontal or vertical. If the vertex, if it's like it's wider than it is tall, then we go right and left our vertex. And then the second part is called a co-vertex. The co-vertex is on what's called the minor axis or the smaller axis. These do have focus or foci, because that's the plural of focus, and those lie on the major axis. So if it's wider than it is tall, then the focus is on the same, that horizontal axis, the same as the vertex. If it's taller than it is wide, which is the one on the right-hand side, so it's vertical, the foci, again, the plural of focus is foci, the foci is on the vertical axis because that's where the vertex is. Now, all those pieces of information, there's an A, a B, and a C. The A, and this is going to be true for both ellipses and hyperbolas, is the distance, so you're going to want to write this, the distance from the center to the vertex in both directions. A is the distance from the center to the vertex. If it's vertical, we go up and down that distance. If it's horizontal, we go right and left that distance. B is the distance from the center to the co-vertex. And we go the opposite direction. So if we're going right and left, A, we're going up and down B, or vice versa. And C is the distance from the center to the focus. You will always be given enough information to determine 2 of these 3, and then you're going to see in a minute there is a relationship between these 3, so you can find the third one. So A to vertex, B to co-vertex, C, God bless you, to focus. A and C will be on the major axis. So if it's vertical, we go up and down those 2. and B is on the minor axis. So if it's vertical, we go up and down the A, right and left the B. If it's horizontal, we go right and left the A and the C, and we go up and down the B. All right. These are the equations of the ellipses. So notice that the vertical and horizontal, the only change is what comes first. Okay, and it doesn't always have to be this way. We're going to play with this a little bit, but you'll see. These all have to be equal to 1. So the first thing you're going to do is make sure it's equal to 1. If it's got anything on the other side of the equal sign, we're going to divide by it, because that's the first thing you're going to do. And then if there's no shift off of center, then you're going to see just an x squared and a y squared in the numerators. If there's something in the numerator with the x or y squared, that's what shifts it off of center. God bless you. The A is the bigger denominator. God bless you. And that's also really important. So add it on there. A is the bigger denominator. And that's what's going to determine if it's horizontal or vertical. If the bigger denominator is under the x, like this one, it is horizontal, which means it's going to be wider than it is tall. And if the bigger denominator is under the y, like the second one, then it is going to be vertical, which means taller than it is wide. You can follow the little guide underneath there, like this table. For some people, they don't like to they actually like the coordinate points and being able to plug stuff in. For me, I'm a visual person, I'd rather graph it. So we're going to do it that way, but know that you can always come back to this. And the relationship with A, B, and C is that C squared equals A squared minus B squared. So similar to your Pythagorean theorem, but not the same, because in the Pythagorean theorem we add them, okay? C squared equals A squared minus B squared. The length of the major axis is 2A, because we go up and down A, or right and left A. And the length of the minor axis is B. We go right and left the B, or up and down the B, depending on if it's vertical or horizontal. Those will come back mostly into play when we do the equations. So you'll see that tomorrow, like when we have to write the equation. All right, we're going to dive right in. This says to graph, find the vertices, covertices, and foci. So the first thing we have to look for is what? What did I say? What has to be on the other side of the equal sign? 1. Is there a 1 there? No, so we divide everything by what's there. We're going to divide each part by 64. Has to be equal to 1. So 4 goes into 64 16 times, and this becomes x squared over 16 plus y squared over 64 equals 1. Now, which is the bigger denominator? 16 or 64? 64. What variable is it under? Y, which means this is going to be vertical. This is going to be taller than wide, or vertical, because the larger denominator is under the y. It has nothing to do with the order. The other thing you can notice immediately from your equation is there's nothing adding or subtracting from the x or the y, which means my center is at 0, 0. If there was something there, that'd be the h, the k. Now we find A, B, and C. A is the larger denominator. So A squared is 64. A is 8. So what's there is squared. If you look back on that equation, what's there is squared. B squared is the smaller one, which is 16, and we square root it to get B, which is 4. And then the relationship between A, B, and C is that C squared equals A squared minus B squared. So C squared equals 64 minus 16. C squared equals 48. And C would equal the square root of 48. No, oh, good question. We go in both directions, so you don't need it to be the plus or minus. It technically would be plus or minus. But by moving it up and down, we just use it as positive, and then we just move it. But we do have to break this down. This would be 3 and 16. Square root of 16 comes out as 4. So this is 4 square root 3. Now I'm going to bring in a graph. Why is it spinning? And we're going to plot what we know. So I know my center is at 0, 0. And I know it's vertical because the larger denominator was under the y. So I go up and down A, which is going to be bigger than B. A is 8, which means from here I go up 8 and down 8. And those are my vertices. So 0, 8 and 0, negative 8. Then I go right and left my B, and my B was 4, so I go right and left B, and those are my co-vertices.
How did you get 8?
A squared was 64, so A is 8, and that's going to be your major axis, so that's your vertices. And then already I can make my ellipse. So it doesn't have to be perfect. Try to make it fluid. Try not to make it sharp edges, but it doesn't have to be perfect. It should be oval in shape. Yep.
So are the vertices what B is?
B is your co-vertice. So A, like the up and down, was our vertice, right? And A was 8. And then B is your co-vertices, which was 4. So we went right and left. And then the the foci, we go up and down C. Since C is the 4 square root 3, this is not a whole number. We got to approximate it. And for that, we would go back to the square root of 48, which is a little bit less than the square root of 49, which means this is going to be, a little bit less than 7, right? So this could be like 6.9. Doesn't have to be perfect. But when we graph it, we want to approximate where that would be. Those would be your foci. Which means we went up and down 4 root 3. So 0, positive 4 root 3, and 0, negative 4 root 3. When you give the vertices or whatever the coordinate points, you will keep it exact. When you graph it, you're going to approximate. Questions so far? All right, we're going to do it again. This time, what do we notice about what's on the other side of the equal sign? It's already 1. I don't have to do anything first. It has to be 1. If it wasn't 1, we would divide, but I don't have to do anything yet. Now I want to look and see which is the bigger denominator. 9, which is under which number? Which letter? X, which means this is horizontal. This is going to be wider than it is tall. I know that because the bigger denominator is under the X. I know my center is 0, 0 because there's nothing after the X or the Y. A squared is the bigger denominator, so A squared is 9, which makes A 3. And B squared is 5 because it's the smaller denominator, which makes B square root 5. With me so far? So then I need to find C. Relationship is C squared equals A squared minus B squared. So C squared equals 9 minus 5, which is 4. If C squared equals 4, then C is 2. Good. Now I go to my graph and plot all the things I know. Center is what? 0, 0. A is 3, but what direction am I using A? Up and down or right and left? Right and left. So I go to the right 3 and to the left 3, and those are my vertices. Negative 3, 0, and 3, 0. Made.
Why is A wait, never mind. Wait.
You sure?
Why is A B? Why is it not square root of 5?
A bigger one is A, always. Doesn't matter the order. Order is going to matter when we get to like hyperbolas, which have a minus between them, but ellipses, it's always the bigger one. All right, then B is square root 5. So we're going to go up and down square root 5. What perfect square root is 5 closest to? 4, which would mean it's a little bit bigger than 2, right? So we're going to approximate this, even if it was 2.1. It doesn't matter. It's just a little bit bigger. So we're going to go up around 2.1. And that's my co-vertices. When I write them out, I keep them exact. So co-vertices, we go up and down square root 5, which means 0. Oops, I don't know why I put the square root there. 0, square root 5, and 0, negative square root 5. Now already I can make that shape. Again, it doesn't have to be perfect. And then the last thing I need to find is my foci. The foci, this time, the C is a whole number. It is 2. And we put it on the major axis, which this time is the horizontal. So we move in the same direction as the vertices, 2. Which means my foci are here and here. So right and left, 2. Negative 2, 0, and 2, 0.
What are the two like check marks on the outside?
There are V's for vertices. Like the pink dots are the vertices. I just made it a V so we know the difference. And then I put CV on the other one so we know the difference. You don't even have to label it on your graph. I just do it as like I have it. All right, so now what happens when our center's not at 0, 0? Everything except for the first initial spot is the same. What you will see is there will be something in the numerators with my variables, and that's how you'll know the center is not at 0, 0. So if it is the x minus h and y minus k, the hk comes out just like we did with parabola. You change the sign on the h, you change the sign on the k because it's a minus in the original equation. And then everything else is the same, except that we don't have zeros in our answers anymore. It's not like 0a and 0 negative a. We have to come from the center. So if you graph this, which is what I would strongly recommend, then it shouldn't be too bad because you'll see it from your graph, okay? But that's the difference. Everything else is exactly the same. The a is still the larger denominator. It still determines if it's vertical or horizontal. The only thing that changes is where you're initially starting from, what your center is. All right, so look at 3. Again, same set of instructions. Graph, find the vertices, co-vertices, and foci. So the first thing that I pick out here is that my center's not at 0, 0. So I will write center. I change the sign on what follows the x, which may not always be the first thing, so be careful. That's 2. I change the sign on what follows the y. That's negative 1. Now I know my center's not at 0, 0. Then I figure out which is the bigger denominator, which is what? 16, and 16 is under the y, which means this is vertical. Good. A squared is 16, which makes A 4. B squared is 9, which makes B 3. C squared equals A squared minus B squared. So C squared equals 16 minus 9, which is 7. And C would equal the square root of 7. This is where the graphing is really going to help you because you're going to figure out your coordinate points from the graph. My center is 2, -1. So my center is now here. I'm coming off of this coordinate point. It's vertical, so I'm going up and down the A. Up 1, 2, 3, 4, and that coordinate point is 2, 3. Down 1, 2, 3, 4, and that coordinate point is 2, -5. Those are your vertices. So I think easiest way to find them is literally plotting that point. The other way to find them is take your center, and the K is what you're changing because you're going up and down. You would add and subtract A, which is 4. So -1 minus 4 gives you the 2, -5. -1 plus 4 gives you the 2, 3. You could do it either way. So if you prefer the graph, that's what I would recommend, but you can also do it without a graph by adding and subtracting. This time, because it's vertical, we'd add it to the Y.
Wait, why are you subtracting 4?
Because 4 is your A. So that's how far we go up and down. Now we go B. B, we go right and left. 1, 2, 3, 1, 2, 3. And those coordinate points are 5, -1, and -1, -1. So those are your co-vertices. If we didn't have the graph, we would find them by taking the X coordinate and adding and subtracting the B, which is 3. So 2 minus 3 gave me the -1, -1, and 2 plus 3 gave me the 5, -1. Now I draw my ellipse. And then the C, I go up and down because this is vertical, √7, which is approximately, it's in between √4 and √9, so we could just make it a 2.5. Up 2.5, down 2.5. What we've done is taken that 7 and added and subtracted it to the Y coordinate of my vertex. So 2, -1 minus √7, and 2, -1 plus √7. So the foci goes again on the vertical axis this time because this is a vertical ellipse. Yep.
Why is the center why is the center 2, -1?
Because it comes from your equation. So this, right, the X, what follows the X, what follows the Y, but change the sign.
Oh, I thought the center was 2, 3.
All right, we're going to do the last one. What's different this time? It's not equal to 1. And the second one has no denominator yet, right? But we got to divide by 16 before we can determine anything. What happens when you divide a fraction by a fraction? I've been multiplying by the reciprocal, right? So x plus 3 squared would go over 64. And then y minus 3 squared would go over 16. Now from here is where I determine if it's vertical or horizontal. Which one's got the bigger denominator? X, which means horizontal. What's my center? -3, 3. Change the signs. My A squared is 64. My A is 8. My B squared is 16. My B is 4. Yep. Oh, after I do this one though. Okay. C squared is 64 minus 16, which is 48. And we did this already. Square root 48, which is what we're going to graph. But 4 root 3, sorry. 4 root 3 is the simplified version of that square root. I go to my graph. Negative 3, 3 is my center. It's horizontal, so we go right and left the 8 this time. So 1, 2, 3, 4, 5, 6, 7, 8 to the right, and that is 5, 3. 1, 2, 3, 4, 5, 6, 7, 8 to the left, and that would be negative 11, 3. Those are the vertices. Co-vertices, B is 4. So I'm going up 1, 2, 3, 4, down 1, 2, 3, 4. Those coordinate points are negative 3, 7, negative 3, negative 1. Those are your co-vertices. And then your foci, you're going right and left for root 3. Oh, this is exact, not approximated. This is exact. This would be like 6.9. 1, 2, 3, 4, 5, 6.9. And those are your foci. We're going to keep them exact when we give those, though, which means we're taking the x coordinate of my center, adding and subtracting for root 3. So when you write these, you can actually write them as like negative 3 plus and minus 4 root 3, 3. Now I am going to publish the web assign for ellipses. It is going to be both parts though. So it's going to have this and then it's going to have the equations. So it will be due. It's not going to be due tomorrow. It will be due Friday. But keep in mind that it's going to be long because it's got those two parts. So you definitely want to get a head start on everyone that says to graph, find the vertices, find all that stuff, okay? So again, I'm going to edit it so that it has both to get together, but it gives you an extra day. So we can do a little bit more practice on it tomorrow. I'll put in the instructions on the Canvas assignment which ones I would recommend you do today, okay? And then at least get your feet wet while that's kind of fresh in your mind. And then tomorrow we're going to do the flip-flop where you get the information and you've got to give the equation. Questions? Make sure you are graphing these. So even if it's multiple choice and you're selecting the multiple choice graph, you need to make sure you're showing the work for the graph. It doesn't have to be perfect, but you need to show the work for your graph in your work, okay?